Everyone. I'm Kamini Singha. I'm super excited to have you all here. I am the PI of a National Science Foundation funded grant that is supposed to coordinate research. So part of the idea of this is to bring people together. And this seminar series is part of what we are doing. We are super excited to have you here. The whole idea of this series is to introduce people that are interested in earth and environmental science to topics maybe they haven't had the chance to be introduced to before. So we're expecting you to come in with interest and enthusiasm, but no experience in these topics. This seminar series is in part developed from, some of you may have been at the meeting, the Cyber Symposium we held last June, where students in particular and early career researchers asked for the opportunity to meet with people to sort of in the critical zone community, this integrated earth and environmental science community, to get to know a little bit more about what's happening and meet with some of the people within it. And so the whole idea is we're going to have these short research seminars. I'm about to introduce Julia Perdrial, who's amazing, who's going to talk about an introduction to CZ science. And then we're going to have some breakout rooms. And I certainly hope you stay for them. On your registration, you already indicated which room you would be most interested in, and we'll talk more about that in a moment. But it'll put you in a room with some people and you'll talk about things like careers or applying to graduate school if you are an undergraduate, something about working in teams, navigating white spaces in critical zone science as a BIPOC scholar. We have a bunch of rooms that we will put people in. You are welcome to move rooms if you would like, but we hope that you participate in these and feel welcome here and get something out of today. So with that, let me hand it over to the MC for today, who is Julia Perdrial. She is a faculty member at the University of Vermont, and I am very excited for her series today. So Julia, I'll hand it to you.
Yeah, thanks so much for having me. And I'm so excited to be here. It's Friday, spring is coming. I'm in Vermont up here. So sun is out and everything just feels so much better already. So I'm gonna just figure out how to share my screen. Please let me know if you cannot see anything. I'm teaching online, like a lot of us during the pandemic, and even I'm doing this since over a year now. There's always those hiccups. So yes, I'm kicking this off, Critical Conversations, Introduction to the Critical Zone. And before I even wanted to get into more like the nitty gritty of this, I would love to hear from you how you are doing. And so Julia Masterman is going to put out a poll for you to answer in the chat, or it might just show up on your screen. How are you doing? And you should be able to give us a range of answers, clicking all that apply. And I'm seeing the poll evolving in real time. So it sounds like a lot of us are so over the pandemic for sure. Yes, so we're gonna give this just a few more seconds. You are all really fast with submitting your answers here, but definitely a good mix. Some of us are hungry, yes. Depending on your time zone also, it's about lunchtime for me for sure. But yes, we're all over the place, right? I find in the past year, whenever I ask my students in class how they're feeling with polls like that, it was everything at the same time. Great, curious, anxious, worried, happy, sad, everything at the same time. And I think that's pretty much where we are right now. But I'm with you. So over the pandemic, excited, curious. Okay, thank you so much for showing where you are. And nobody's sad just right now, which is also amazing. Okay, so I want to give you a quick outline, or also known as what's about to happen. And I'm going to probably talk for 20 minutes only so that we have enough time for breakout rooms. But what I'm going to talk about is the critical zone, the interdisciplinary science part of critical zone science, and the importance of perspectives and teamwork. But I'm also going to talk about zebras and art, about pizza, and about elephants. So, and I hope that will make sense just in a moment. But also before getting even into what the critical zone is, I thought I'd give you a little bit of a story of how I got to critical zone science. Also because one of the breakout rooms is passed to interdisciplinary science and do we ever know what we want to do? Because that's very true for me. So here, this is me then, and then could be pretty much any time, but here maybe after high school. And then me now, later. And for some people, it's a very straightforward path that you can navigate straightforward too. That was not the case for me at all. I had a very squiggly path, and my assumption is that this will just continue to go that way. And the thing was that I just was interested in so many different things. I really liked art. And so I thought, well, I might apply to art school. And that led through a change of plans that was covered in a lot of humility and realizing that enthusiasm and talent might not be the exact same thing. And then I was interested in other things also. I really loved psychology. And just because I find it so interesting, what motivates people, right? Why do we do the things we're doing? So I did a bunch of internships, and that also led to a change of plans because I realized, well, I love this and I want to know more about it, but I might not want to do this as my job. And then geology was the next thing, which was more like a hunch after all this kind of thinking and trying things out. I wanted something really solid where I could literally plant my feet on, which I thought the earth is a good place to do that. And then it hit me and I started studying all these other fields like mineralogy and geochemistry, geomicrobiology for my PhD, and then later soil science and biogeochemistry and all these kinds of things. They're actually part of critical zone science. And that's the area that I'm kind of shading in green right now. That's what I think of what really comes together in critical zone science. But I would even argue that all the other pieces that I haven't shaded are part of this too. And what I love about critical zone science is that people with all these different paths, whether they're straight or squiggly, come together and bring their perspectives and their disciplines to there. And that's what we need. So I haven't told you yet what critical zone really is. Here's an official definition. It's the heterogeneous near surface environment where we have complex interactions, lots of stuff, rock, soil, water, air, living organisms that regulate the natural habitat and our life sustaining resources. So it's a pretty important place. And that's why the National Research Council said that is critical. We call it the critical zone. And there's another piece of definition that often people use is that it extends from the tops of the tree canopies all the way down to the actively cycled groundwater. So it's kind of a really large place of the Earth's surface. And I warned you that I was into art, so I'm going to use a piece of art to show you, in my mind, what makes critical zone science so special. So this is a piece of art, Zebras by Victor Vasarely, and I like it because it's actually very simple, but looks really dynamic. And here's another version of this that is tidied up by a Swiss artist who's called Ursus Verli, and he does this. He cleans up art, and you can look it up under www and then Kunstaufräumen, it's Swiss German. And it's in itself really nice and beautiful, right? All he does is that he takes the shapes and stacks it by size and shape, and it looks great in itself. But what happens is that the entire meaning is lost because the meaning comes from the context. So if we only had the tidied up version and somebody would tell us, take that version and reconstruct it and make something out of it, we could come up with stuff, but we probably would not come up with the zebra pictures. So what the connection to critical zone science is that when we go outside and sample the natural world and do our observations and select data, we get a lot of stuff, right? Plant stuff, and we go out and we get some soil stuff, and we go out and we get some rock stuff and water, and all of these different pieces are fine, but that is single zebra stripes. We need to put this back together in context, and that's what critical zone science does really well. Another example of how to frame this is from Dr. Sue Brantley, who's really one of those first critical zone scientists. And she uses that example of a weaving pattern. Like if a single discipline would just come in and pull out a single thread and looked at this and studies the heck out of this and knows everything about that single thread, it would still not tell us anything about the pattern. So we have to always look at this in the context. So critical zone science is done by a lot of people. This is one resource if you're interested. Look it up, the Critical Zone Exploration Network. And they have a site finder. So you can see that critical zone science is done globally, right? So all these sites here, and there's more coming. Here in the US, we just got a new round of funding to support critical zone science. And I put this green dot here again, that is kind of like my squiggly path, and then everybody else's squiggly path that works on the big data team. The official name of our project is using big data to assess eco-hydrological resilience across scales, but even I get this like messed up. So we're just like, okay, we're simplifying this. We're big data now. And there's a lot of other projects. They all had complicated names, but they're now just coastal, dust, urban. And then there's this hub in between, and you've met Julia Masterman from the hub. There's a couple of folks from the hub here. They're essentially coordinating everything that we do. And then we're also working with each other. So it's this growing collaborative network, and we want more collaborators. And that's why we're so excited that so many people are signing up for these webinars. So critical zone science is interdisciplinary science, right? And I want to use this analogy. So for everybody who's hungry, I apologize, I'm not going to help here. But if we have these single ingredients, right, they're great. And if we put them together well, we can make something amazing with this. And you might argue that a pizza is more than just taking cheese, tomatoes, flour, and basil and smushing it together, right? It's so much more. And for this, you also need to know how to put things together. And that's the true art, I think, in interdisciplinary science. So if the pizza is a critical zone, then we have lots of ingredients that we play with. And for example, some ingredients could be data. So here there's a lot of different types of data that probe different areas of the critical zone, and all of them are important. And what's interesting to me is to think about, you know, if you are the one who provides the basil to the pizza, what you need to know is about basil, but you also need to know when to add it to the pizza, if that makes sense. Like my students tell me I'm overdoing it with the food analogy, so I'm gonna hold this, but it's not necessarily to be a specialist in every single thing to be able to do that, but you have to know how to work with each other. I want to give an example also why critical zone science is so important in this interdisciplinary workings of this type of science. So decades ago, some folks realized that fish in rivers and lakes died, and that happened across the northeastern US, that happened in Germany, that's where I'm from, that happened in Asia, that happened in a lot of places. And trees didn't do so well either. People realized, well, stream and soil pH is also not so great. And then there was something going on like with the atmospheric deposition, lots of sulfate and nitrate. So we were thinking about what does a pizza look like in that context? It's not a great pizza, but it's one really important that we need to understand. So bringing all these different disciplines together to understand how atmospheric deposition in one place kills a fish in another place needs a lot of connections. So first you need to look at atmospheric science, right? To understand why, what is going on there? What's the composition of what falls onto the earth? And people realize lots of protons, that's where the acidity is coming from. That fell on the surface of our critical zone on the shallow soil layers and leached out a lot of materials that are actually really important nutrients. They're important for soil health, and they just started to be mobilized. So for this, you need actually somebody who's looking into soil science or biogeochemistry. Lots of folks then also realize that mobilized metals that normally are not mobile, they're solids, but if you get the pH low enough, they can actually dissolve and be present in a solution. So people that know about the bedrock lithology, what's there in the first place and how do elements behave, work on this. This problem then led to trees actually being able to take up some materials that are really toxic to them because now they were soluble. So then you're talking to biologists and ecologists. All of that stuff also leached into the river. So then talking about people that know how water moves and again, what's in there. And that then might also help understand what's happening with the fish. So many different people have to talk to each other and figure this out. Another important example is carbon. We know we have too much CO2 in the atmosphere and it's getting more and we need to figure out how to stop that, but also how this impacts our habitat, right? Our resources. So when we're thinking about how much CO2 is the critical zone breathing in and how much is it breathing back out, we hope that it's breathing more in than it's breathing out, right? But to investigate this, we might look at the different layers of the critical zone. And that's an important difference between ecology, when some of you might be thinking, well, a lot of this is actually ecology. What's different for critical zone science? So in the more shallow layers, we're probably looking at what the soil does. And then we're looking at what's happening in the shallow groundwater. And that's often where ecology stops. And critical zone science includes ecology plus the deeper layers that also includes the bedrock, what happens there. We need to know how the bedrock fractures, where water flows, how it interacts. Maybe we're forming new minerals. So essentially, critical zone science includes the deeper layers of the earth and also that longer timescales that come with it. So I want to make that point that when we have all these different disciplines coming together to look at that thing, that's the critical zone, that's a good thing because we need to be able to understand what we're really looking at, right? And I really like this depiction of when we're only looking at one aspect, we might be really not understanding what we're looking at all. So in this case, if a person just has the elephant's ear and says, well, I'm sure what that is, it's a fan. And the other one has the tusk and says like, well, I'm sure it's a spear. If they can't talk to each other and if they can share all these pieces to come together to make sense of the elephant in the room, then it wouldn't work. So that's such an important piece. So we need a lot of different pieces coming together and really good communication, because otherwise we're putting this together and say, nailed it. And if you've ever seen that show, it's hilarious. A lot of good and bad baking happening in that show. There's another piece to this that I want to mention, and this is that critical zone science is coming out of the geosciences, which traditionally really have been dominated by white perspectives. And I'm saying this as a white woman from Europe who for the longest time did not even realize how white that space really is. And that is very close to a story that a friend of mine tells us, a colleague and friend of mine. And it's about these two fish, like teenage fish. They're swimming in the water and they haven't been around a long time, right? They're like young fish. And they're chatting along in the water. And then there's these other fish coming. It's older fish. It's a little crusty. And that older fish says, hey, how's the water? And the other two fish says, the water's great. And then they go their way, right? And as soon as the older fish is gone, one teenage fish said to the other, what the heck is water? And I find this such a good story because I think for a lot of white folks is white spaces are like water. We don't even see it. And that's a huge problem because when we are looking, it's a big problem for many reasons. One of them is that we're not getting all perspectives in the room. We might have looked at the elephant from that perspective since forever and not even know it. Here's the last point that I want to make, and then I'll let the elephant go. And that is that this specific depiction comes from the Journal for Thoracic Diseases, which is a medical field journal. And the authors make that point that in especially cancer treatments, it's so important that all the different disciplines and medical disciplines talk to each other really well. And if that does not happen, it is to the bad, really detriment to the patients. And I know this from my own family, like a lot of us have stories where ourselves impacted. And it's really important that these disciplines are talking to each other and doing this really well. So I would argue that our Earth has some of these systemic sicknesses as well. There is human-made climate change, pollution, but also social injustice and racism. And I think bringing all these perspectives in a room is important so that we can address this. I want to make this last point, and that is from Dr. Brandon Jones, the NSF program director, who talked to a lot of the PIs on the new network clusters. And he's saying, you know, our planet is facing all hands on deck problems, but all hands are not on deck. And that's, again, I think something where people like myself and everybody who has power has a lot of work to do. And luckily in the geosciences, there is an amazing program that has started, Unlearning Racism in the Geosciences, and a lot of people are involved so that white folks really start doing the work. So in summary, I want to say critical zone science has this huge potential to address some of these really pressing environmental issues that we face today. But for this, we need all hands on deck, and that is all identities, all disciplines, approaches, experiences, and much more. It also needs humility. We need to be willing to listen to each other and learn from each other and be able to work with each other. And critical zone scientists are training in exactly getting that done, right? Not insisting my discipline is the only one that counts, no. And we need more people. So please get involved, help us get there. And how? Well, you're already here. So this is the big first step, or maybe it's the second or the third. Get information on opportunities by signing up at Season, following us on Twitter, signing up for the Hub newsletter. So there's going to be a lot of information and ways for you to get involved. Join the next critical conversations for sure, and then talk to critical zone scientists. The first best way of doing that is in our breakout room. So I'm so excited that we do this, but also contact us via email, like email me, email all of us. Talk to us at conferences. We are always, all critical zone scientists that I know are really happy to just talk to people. And then there's a last piece. My favorite quote from Michelle Obama is, "Don't be afraid to ask for help, because nobody gets through college on their own." And I would say that's true for research, that's true for life. So that's true always. So we will be getting ready for breakout rooms now. And I just wanted to mention one thing for just getting us in the right mindset so that we can all talk to each other in those breakout rooms. And those are meeting norms that we use in my group. And I really like them, and I need them for myself too as reminders. So one would be as present as you can. And that might mean very different things for us. Step up. If you tend to be quiet in big meetings, maybe try and speak up and contribute. And if you find yourself dominating or talking a lot, then maybe step back and tolerate the silence for a moment so that other people can jump in. Definite permission to be raggedy. Half-formed thoughts are very welcome. also, we're going to assume good intentions with what we're saying, but what's more important is to be careful about the impacts. And if we're saying anything that offended somebody, then we figure this out and say, I'm sorry, and that's it. Listen to understand rather than to respond. That's a hard one for me, especially when I'm nervous. I'm just kind of like, somebody says something, I respond. So I'm going to try and work on this. And then I would say also these breakout rooms should be confidential spaces. Learning can come with us, but the stories and specifics should stay in those breakout rooms. So with this, here's just all sorts of email addresses. And I'm just gonna unshare this and wonder if Kamini, if anybody has any kind of anything before we break out.
No, but I will let you know, folks. So when you registered, you did sign up for breakout rooms of the most interest to you, and we've put you in those rooms to begin with. But if for some reason you have changed your mind when I tell you about these, feel free to switch rooms if you would like. You should be able to do that within Zoom. We really hope you get to meet other people in the community too. I think under COVID, none of us have really met anyone in the last year. And I know that meeting people online isn't the same, but I hope you find that the people here are like just as excited as at least I am to meet some new people. So the rooms that have been set up for this, this critical conversations are paths to interdisciplinary science. Do we know what we want to do? There's another that's, and Julia, do you want me to just go ahead and you are running that one, is that correct?
Yes, and I wanted to introduce the other team members of the big data cluster that volunteered to facilitate rooms. See, this is the thing, what happens when I'm done presenting, I'm like, okay, I'm done. But yes, I wanted to introduce Leon Walls. Leon is an associate professor at the University of Vermont in the Department of Education. And Leon is going to facilitate navigating white spaces in geoscience, opportunities and challenges for BIPOC students. And then also I want to introduce Dustin Kincaid. So both have their videos on. Dustin is a postdoc at the University of Vermont, has a lot of experiences with interdisciplinary work, and he's going to facilitate the path to interdisciplinary science. Do we ever know what to do? So because this was a big group, we thought we split it in two halves. So one of you will be with me and the other group will be with Dustin.
And then the other rooms that are happening is, I hope there were undergraduates that signed up. So if so, I am running a breakout room on things I wish I had known before I had applied to graduate school. So some of you have signed up for that room. We have another room that says finding purpose in your career and making your career fit what drives you. That was another popular room. We have two hosts for that. One is Nicole Gasparini, if I can get her to wave. She's at Tulane University. And then Pam Sullivan, who is also waving, who's from Oregon State. And then the last room that we have is working in collaborative teams. And with that, I'd like to introduce Deanna McKay, who is waving also. She's also with QUASI, so the Consortium for the University Advancement of the Hydrologic Sciences. So with that, I don't think there's anything else that I need to say. Julia?
You know what, I wanted to mention one quick thing. So I love that there is a lot of folks from all different career stages signed up. This is fantastic. And I just wanted to mention that we hope to get conversation going, especially with undergraduate students, graduate students, and postdocs. So higher career stages, please join us. But I just wanted you to be mindful to leave a lot of the talking time for the earlier career folks.
Great. With that, Julia, perfect. You're ahead of the game. So you should get an invite for a room. Please join us if you are willing to take the time. We'd love to hang out with you.